Hi everyone. So let's start solving today's LeetCode daily challenge, which is minimum time to complete trips 2187. Okay, let's try to understand the question first. So we have given an ARR time where every index of time represent a bus time to complete one trip. Okay, so each bus can make multiple trips successfully. Next trip can start immediately after completing the current trip. Okay. Also, each bus operates independently. That is, the trips of one of bus do not influence the trip of another bus. Okay. You are also given an integer total trips. Okay. Which denotes the number of trip all buses should make in total. We need to tell the minimum time required for all buses to complete at least total trips. At least total trips, not exactly total trips, but it should not be less than total trips. It can be greater than total trips, but at least total trips should be covered in that minimum time. Okay. Okay. So before approaching the solution or before approaching towards optimization of this code, so we will try to see some observation. So what are the observation here? So if someone asks you like if there is a time given for every trips to you and there are total trips given to you, you should tell me how much time should be taken, not the minimum time. I want the answer of the maximum time. Like, as per you, what should be the maximum time? Can be the answer if the array given to you and number of total trips given to you. So, in if I talk about the maximum time covered in the array, which is let's suppose like let's take 1, 2, 3 only. If the maximum time for any trip and there are total trips given to me as well. What are the total trips? Total trips I need to cover is 5. Can I blindly say the maximum time for every trip for a trip multiply by 5, which is total trips. So the maximum time into total times I can blindly say if the array given to me and total trips given to me, I can blindly say in 15 time I can achieve this number. Blindly. This is my observation, nothing else. Okay. Now this 15 is the maximum time. Okay. If I consider this 1 to 15, so for every time I need to check the whole array, like in one time how many trips I can complete. So how I can see that as well? If 1 is a time given to me, so I can complete 1 by 1. If one time is given to me, 1 by 2 plus 1 by 3. So can I complete if one time is given to me and the trip should complete in one time? Time unit, time, can we say time unit? Okay, time unit is 1. If time is given to me 1 and the time taken by this trip to complete is also 1, I can complete this trip one time. Okay, but this trip can take, but this trip will take 2 unit of time to complete one trip. Okay, so can I complete this in 1 unit of time? No, 0, 0, which is 1 only. 1 is very less than what are the total trips? 5. Okay, so in this way, I need to check for 2, 3, 4, 5, 6 till 15. So as per my observation, if at any point I got the minimum time where I can complete total trips at least 5, in the worst case scenario, what I can say that so for every time unit I need to check the whole array. So in worst case, what can be the maximum time? So maximum time in the array multiplied by total trips. Now for every time I need to check the whole array. So the time complexity for my brute force approach, it will not come exactly this, but it will be less than this. But in the worst case scenario, I can say that my time complexity will be less than max time into total trips. For these much टाइप इतने यूनिट्स ऑफ टाइम के लिए मुझे हर बार एन लेंथ एरे को ट्रैवर्स करना पड़ेगा to check to verify I am able to complete at least total trips number. Okay, so let's see. Now we got the brute force approach. Let's try to optimize this. So let's take this example. Let me write the indexes here. Okay, so this how can I approach this problem using binary search? Because how binary search? Because in like I need to find out time, and for every time I need to iterate the whole array. So how can in a particular range, how optimally I can find that particular time? That for that I use binary search algorithm. Binary search algorithm is the best for doing these kind of questions where I need to pick one element from a range. Okay, so this concept is nothing but known as binary search in answer space. What does answer space mean? I will tell you everything. Okay. Okay. So for binary search, I need two things. I need left, I need R, and I need two conditions where I can increment my left and where I can decrement my R as per my mid value. Correct? Okay. So what can be L? L is a minimum time unit where I can complete total trips. So L should be 1. What can be the maximum as per our observation above? The maximum should be maximum time to complete a trip, maximum time in the whole array, which is this 3 into total trips. So R is nothing but 30. Okay, let's see. If I take my L and R and mid, if I take L, R is 30, mid is nothing but 15. So a mid, what is mid here? Mid is nothing, came here a time unit. I need to check in 15 unit of time, can I complete at least 10 total trips? So how can I check that? If 15 is given to me, so I will write 15. If 15 is given to me, index 0, I can complete 15 by 1 trips. For second index, 5 by 2, 15 by 2. For second index, 15 by 3. And for fourth index, 15 by 1. So how many total trips I can cover in this time unit? 15, 7, 15 by 3 is 5 plus 15. 20, 20 plus 5, 15 is 35 plus 7, 42. 42 which is greater than 10. I need to cover at least 10. It can be maximum. Okay. But from 42 what I observed that in 15 unit of time I can cover 42 total trips, but I need to reduce that because I need to find out minimum time. Okay, so how can I reduce this? I can do not modify my left, I can modify my R pointer, that I can reduce my search space. Now my search space is from 1 unit of time to 15 unit of time. Now if I find out the mid, 15 plus 1 is 16, and it will come as mid is nothing but L plus R by 2. Okay. Now 8 unit of time I got. In 8 unit of time I need to find out how many trips I can cover. So how can I find out 8? 8 by 1, 8 by 2, 8 by 3 and 8 by 1. 8, 4, 2, 8, which is nothing. 8 plus 2 is 10, 14 and 22. 22 is also came out greater than 10, so I can now more reduce my search space. So how I can reduce 1 to 8. Now my search space become from time unit 1 to 8. In this particular time unit, I need to check how much total trips I can cover. So I will find out the mid. Mid is nothing, 8 plus 1 9, 4. Let me check out for 4. If 4 given to me, how many total trips I can cover? So how I can check for 4? 4 by 1, 4 by 2, 4 by 3, and 4 by 1. These numbers are nothing, just a uh, element present at each index. So if I write down the index, so you will get more clarification. 0, 1, 2, 3. For every element of the array, I am checking if 4 unit of time given to me, how many trips I can cover. So if I compute this, 4, 2, 1, and 4. So 4 plus 4 is 8, 11. 11 is still greater than 10. I need to cover at least 10. So how I need to reduce, I can reduce my search space more. Okay. So 1, 2, 4. Okay. Now the medium will be, mid value will be 4 plus 1, 5. 5 by 2 is 2. Now I need to check for 2. Okay. 2 by 1, 2 by 2, 2 by 3, 2 by 1. 2 by 1 is nothing, 2 plus 1 plus 2 by 3 will become 0. What it means, like in 2 unit of time given to me, I cannot complete a trip which will take 3 unit of time. So 2 plus 2, 4 plus 1, 5. 5 is less than 10. How much total trips I need to cover? At least 10. So I can reduce my search space more now by incrementing my left. So left will be 2 plus 1, 3, mid plus 1, which is nothing, mid plus 1. Sorry, this is I. Okay, 3. And what is my R? R I am not changing. So 3 plus 4 is 7. 7 by 2 is 3. Okay, now I need to check for 3. Okay, and 3 plus 4 is 7. 3. Okay, 3 by 1. Let me check for 3 unit of time. 3 by 2, 3 by 3, 3 by 1, 3, 1, 1, 3. 6 plus 2 is 8. Still it is less than 10. I need to increment my left, which is come out to be 4. 4. 4 plus 4 is 8. 8 by 2 is 4. Okay. And at this point, L is equal to R. So in binary search at this step, we will stop. So let me compute for 4 as well. 4 by 1, 4 by 2, 4 by 3, plus 4 by 1. So 4, 2, 1, 4. 4 plus 4 is 8. 8 plus 3 is 11, which is greater than 10. And here 4 is my answer. Okay. So I can simply return when L is equal to R, or when L get greater than R, I can simply return L. Okay. So in this case, I returned 4 here. So let's talk about the time complexity and space complexity. If I talk about the time complexity, so I am reducing my search space half, 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 half. Every time I'm reducing the search space into half. So what I'm reducing my search space? So log of 2, which is maximum time in the array, multiply by total trips, and every time for this I am checking the whole array n. So my time complexity become order of n time log of, I cannot say n here because my search space started from this only. So this is my time complexity. And what if I talk about space complexity? I am not using any extra space, so space complexity will be constant only, which will be order of 1. Okay. Okay, so let me give you a walkthrough of code as well. Okay, so here I initialize my L. I find out the max time of the array and I find out my R pointer. And for every L and R, I am reducing my search space and I return one helper function. What does the helper function do? Helper function is doing nothing, getting a mid parameter. With the help of this mid parameter, what we did above, the function is doing the same. Trips count plus is equal to mid by time of I. Time of I is nothing, all the elements of the array. And here I am returning if I am getting satisfied from that particular unit of time, then I am returning true, either I am returning false. If I am returning true here, so I am reducing my search space from doing R is equal to mid, else I am incrementing L is equal to mid plus 1. Okay. So in this two steps, I am reducing my search space and at the end I am returning the L. So I think the video will help you. Okay. Thank you.